According to the National Electrical Code, specifically Article 200.10b, conductors of different systems occupying the same wireway or enclosure shall have readily identifiable markings. However, there's an important exception outlined in Article 200.10c that directly addresses multiwire branch circuits. This exception significantly impacts the requirement for distinct neutral conductor identification in scenarios where multiple systems share a common wireway. Let's delve deeper into the specifics. Article 200.10c focuses on multiwire branch circuits and provides clear guidelines for neutral conductor identification in these configurations. The article states that for multiwire branch circuits, the neutral conductors shall be identified in one of two ways. Firstly, by marking the neutral conductors of all phases of a circuit with the same white or grey color. Secondly, by marking the neutral conductors of each phase of a circuit with a distinctive white or grey marking. This means that within a multiwire branch circuit, all neutral conductors associated with that circuit must share a common color, either white or grey. Alternatively, each phase of the multiwire branch circuit can have its own distinctive white or grey marking, allowing for differentiation between phases while still adhering to the general color scheme. To understand the implications of this exception, it's crucial to define what constitutes a multiwire branch circuit. A multiwire branch circuit is a circuit consisting of two or more ungrounded conductors having a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit, and which is connected to the neutral or grounded conductor of the system. Essentially, it's a circuit that shares a common neutral conductor. Now, let's consider a scenario where you have two separate systems, each feeding its own panel board, and both systems utilize multiwire branch circuits. Furthermore, these systems share a common wireway for their conductors. In this situation, Article 200.10c allows the neutral conductors of both systems to be identified with the same white or grey color. This is because the exception for multiwire branch circuits overrides the general requirement for readily identifiable markings for conductors of different systems in the same wireway. The key takeaway here is that the exception in Article 200.10c applies specifically to multiwire branch circuits. If the circuits in question are not multiwire branch circuits, then the general requirement of Article 200.10b would apply, necessitating readily identifiable markings for conductors of different systems. However, if the circuits are indeed multiwire branch circuits, then the neutral conductors can be identified with the same white or grey color, regardless of whether they belong to different systems sharing a common wireway. It's important to note that while the NEC allows for the same white or grey color for neutral conductors in multiwire branch circuits, it's still crucial to ensure proper identification and labeling of all conductors. This includes clearly marking the phase conductors and ensuring that all connections are made correctly. Proper identification and labeling can help prevent confusion and ensure the safety of electrical workers who may need to work on the system in the future. Furthermore, it's always a good practice to consult with local authorities and inspectors to ensure compliance with all applicable codes and regulations. Local jurisdictions may have specific requirements or interpretations of the NEC that could affect the installation. Therefore, it's essential to stay informed and seek clarification when needed. In summary, Article 200.10b of the NEC requires conductors of different systems in the same wireway to have readily identifiable markings. However, Article 200.10c provides an exception for multiwire branch circuits, allowing the neutral conductors of these circuits to be identified with the same white or grey color, even if they belong to different systems sharing a common wireway. This exception applies specifically to multiwire branch circuits and does not override the general requirement for readily identifiable markings for other types of circuits. Always ensure proper identification and labeling of all conductors and consult with local authorities to ensure compliance with all applicable codes and regulations. Now let's explore the broader context of neutral conductor identification within electrical systems. Neutral conductors play a critical role in carrying unbalanced current back to the source, ensuring the proper operation of electrical equipment and preventing voltage imbalances. The NEC provides detailed requirements for the sizing, installation, and identification of neutral conductors to ensure safety and reliability. In addition to color coding, neutral conductors must also be sized appropriately to handle the maximum unbalanced load they are expected to carry. The NEC provides specific tables and calculations for determining the minimum size of neutral conductors based on the type of load and the characteristics of the circuit. Furthermore, neutral conductors must be properly grounded to provide a low impedance path for fault current to return to the source, helping to protect against electrical shock and fire hazards. The grounding system must be installed in accordance with the NEC and must be regularly inspected and maintained to ensure its effectiveness. When working with neutral conductors, it's crucial to follow all safety precautions and use appropriate personal protective equipment. This includes wearing insulated gloves, safety glasses, and other protective gear as needed. Always energize circuits before working on them and use lockout/tag-out procedures to prevent accidental re-energization. In addition to the NEC, other standards and regulations may also apply to the installation and maintenance of electrical systems. These standards may include requirements from organizations such as the National Fire Protection Association (NFPA), the Institute of Electrical and Electronics Engineers (IEE), and the Occupational Safety and Health Administration (OSHA). It's important to be familiar with all applicable standards and regulations and to follow them carefully to ensure the safety and compliance of electrical installations. Now, let's shift our focus to the practical implications of the NEC requirements for neutral conductor identification in various electrical systems. In residential wiring, neutral conductors are typically identified with a white or gray color. This allows for easy identification and helps to prevent accidental connections between neutral and hot conductors. In commercial and industrial wiring, the same color coding scheme is generally followed, although there may be some variations depending on the specific application. For example, in some industrial settings, neutral conductors may be identified with a different color, such as blue or yellow, to distinguish them from other conductors. However, any deviation from the standard color coding scheme must be clearly documented and communicated to all personnel who may be working on the electrical system. In addition to color coding, neutral conductors may also be identified with other markings, such as labels or tags. These markings can provide additional information about the circuit and can help to prevent confusion. For example, a label may indicate the voltage and amperage of the circuit, as well as the location of the panel board that feeds the circuit. When installing or modifying electrical systems, it's essential to pay close attention to the identification of neutral conductors. Incorrectly identified neutral conductors can lead to serious electrical hazards, including shocks, fires, and equipment damage. Therefore, it's crucial to double-check all connections and to verify the polarity of the circuit before energizing it. In addition to the NEC requirements for neutral conductor identification, there are also some best practices that can help to improve the safety and reliability of electrical systems. These best practices include using high-quality wiring and components, following manufacturer's instructions, and performing regular inspections and maintenance. By following these best practices, you can help to ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. Now let's delve into some specific scenarios where the NEC requirements for neutral conductor identification can be particularly challenging. One such scenario is when dealing with existing electrical systems that may not have been installed in accordance with current codes and standards. In these cases, it may be difficult to determine the correct identification of neutral conductors, especially if the wiring is old or damaged. In such situations, it's essential to proceed with caution and to use appropriate testing equipment to verify the polarity of the circuit. Another challenging scenario is when working with complex electrical systems that have multiple voltage levels and grounding configurations. In these systems, it can be difficult to keep track of all the different neutral conductors and to ensure that they are properly identified and connected. In these cases, it's helpful to create a detailed wiring diagram that shows the location of all the neutral conductors and their connections to the grounding system. This diagram can serve as a valuable reference tool for troubleshooting and maintenance. Furthermore, it's important to clearly label all neutral conductors and to use consistent color coding throughout the system. This will help to prevent confusion and to ensure that all personnel working on the system are aware of the correct identification of the neutral conductors. In addition to these challenging scenarios, there are also some common mistakes that can lead to problems with neutral conductor identification. One common mistake is to assume that all white or grey wires are neutral conductors. While this is generally true, there are some exceptions. For example, in some cases, a white or grey wire may be used as a hot conductor, especially in switch loops. Therefore, it's always important to verify the polarity of the wire before making any connections. Another common mistake is to fail to properly ground the neutral conductor. A properly grounded neutral conductor is essential for preventing electrical shocks and fires. Therefore, it's crucial to ensure that the neutral conductor is connected to the grounding system in accordance with the NEC. In conclusion, the NEC requirements for neutral conductor identification are essential for ensuring the safety and reliability of electrical systems. By following these requirements and by adhering to best practices, you can help to prevent electrical hazards and to ensure that your electrical system is compliant with all applicable codes and regulations. Remember to always consult with a qualified electrician if you have any questions or concerns about neutral conductor identification or any other aspect of electrical wiring. Now let's expand on the concepts of grounding and bonding, which are intrinsically linked to the proper function and safety of neutral conductors. Grounding refers to the connection of an electrical system to the earth, providing a lower impedance path for fault current to return to the source. This helps to trip circuit breakers or fuses quickly, preventing electrical shocks and fires. Bonding, on the other hand, refers to the connection of all metallic parts of an electrical system to create a continuous electrical path. This ensures that all metallic parts are at the same electrical potential, reducing the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding, including the types of grounding electrodes that are permitted, the size of grounding conductors, and the methods of bonding metallic parts. It's crucial to follow these requirements carefully to ensure the safety and effectiveness of the grounding and bonding system. One important aspect of grounding is the concept of the grounding electrode system. The grounding electrode system consists of one or more grounding electrodes that are connected to the earth. Common types of grounding electrodes include metal underground water pipes, ground rods, and concrete encased electrodes. The NEC specifies the minimum size and type of grounding electrode that is required for different types of electrical systems. Another important aspect of bonding is the concept of equipment grounding conductors. Equipment grounding conductors are used to connect the metallic parts of electrical equipment to the grounding system. This ensures that all metallic parts are at the same electrical potential, reducing the risk of electrical shock. The NEC specifies the minimum size and type of equipment grounding conductor that is required for different types of electrical equipment. In addition to the NEC requirements for grounding and bonding, there are also some best practices that can help to improve the safety and reliability of electrical systems. These best practices include using high-quality grounding and bonding components, following manufacturer's instructions, and performing regular inspections and maintenance. By following these best practices, you can help to ensure that your grounding and bonding system is safe, reliable, and compliant with all applicable codes and regulations. Now let's consider some specific scenarios where grounding and bonding can be particularly challenging. One such scenario is when dealing with existing electrical systems that may not have been installed in accordance with current codes and standards. In these cases, it may be difficult to determine the correct grounding and bonding configuration, especially if the wiring is old or damaged. In such situations, it's essential to proceed with caution and to use appropriate testing equipment to verify the integrity of the grounding and bonding system. Another challenging scenario is when working with sensitive electronic equipment that is susceptible to damage from electrical noise and transients. In these systems, it's important to provide a clean and stable ground reference to minimize the risk of equipment damage. This may involve using dedicated grounding conductors, surge suppressors, and other specialized grounding techniques. In addition to these challenging scenarios, there are also some common mistakes that can lead to problems with grounding and bonding. One common mistake is to fail to properly bond all metallic parts of the electrical system. This can create a potential difference between metallic parts, increasing the risk of electrical shock. Another common mistake is to use the wrong size or type of grounding conductor. The grounding conductor must be sized appropriately to handle the maximum fault current that it is expected to carry. In conclusion, grounding and bonding are essential for ensuring the safety and reliability of electrical systems. By following the NEC requirements for grounding and bonding and by adhering to best practices, you can help to prevent electrical hazards and to ensure that your electrical system is compliant with all applicable codes and regulations. Remember to always consult with a qualified electrician if you have any questions or concerns about grounding and bonding or any other aspect of electrical wiring. Now let's discuss the specific NEC articles that are most relevant to the identification and installation of neutral conductors, grounding conductors, and bonding jumpers. These articles provide detailed requirements for ensuring the safety and proper functioning of electrical systems. Article 250 covers the general requirements for grounding and bonding. This article specifies the types of grounding electrodes that are permitted, the size of grounding conductors, and the methods of bonding metallic parts. It also includes requirements for grounding sensitive electronic equipment and for minimizing electrical noise and transients. Article 300 covers the general requirements for wiring methods and materials. This article specifies the types of wiring methods that are permitted, the installation requirements for different types of wiring, and the requirements for protecting conductors from physical damage. Article 310 covers the requirements for conductors for general wiring. This article specifies the types of conductors that are permitted, the ampacity of conductors, and the requirements for directing conductors when they are installed in raceways or cables. Article 408 covers the requirements for switchboards and panel boards. This article specifies the construction requirements for switchboards and panel boards, the requirements for overcurrent protection, and the requirements for grounding and bonding. Article 500 covers the requirements for hazardous classified locations. This article specifies the types of equipment that are permitted in hazardous locations, the installation requirements for equipment in hazardous locations, and the requirements for grounding and bonding. In addition to these specific articles, there are also many other NEC articles that are relevant to the identification and installation of neutral conductors, grounding conductors, and bonding jumpers. It's important to be familiar with all of these articles and to follow them carefully to ensure the safety and compliance of electrical installations. Now, let's discuss some of the key changes that have been made to the NEC in recent years. These changes reflect advancements in technology and evolving safety concerns. One significant change has been the increased emphasis on arc fault circuit interrupters of size. SIs are designed to detect arc faults, which are a common cause of electrical fires. The NEC now requires FSIs in many locations, including bedrooms, living rooms, and dining rooms. Another significant change has been the increased emphasis on ground fault circuit interrupters GFCIs. GFCIs are designed to detect ground faults, which can cause electrical shocks. The NEC now requires GFCIs in many locations, including bathrooms, kitchens, and outdoor areas. Another significant change has been the increased emphasis on surge protection. Surge protectors are designed to protect electronic equipment from voltage surges which can damage or destroy sensitive components. The NEC now requires surge protection in many locations, including service entrances and panel boards. In addition to these specific changes, there have also been many other changes to the NEC in recent years. It's important to stay up to date on these changes and to follow them carefully to ensure the safety and compliance of electrical installations. Now, let's discuss some of the resources that are available to help you stay up to date on the NEC and other electrical codes and standards. One valuable resource is the National Fire Protection Association (NFPA). The NFPA publishes the NEC and other codes and standards related to fire safety. The NFPA also offers training and certification programs for electrical professionals. Another valuable resource is the Institute of Electrical and Electronics Engineers (IEE). The IEEE publishes standards related to electrical engineering and electronics. The IEEE also offers training and certification programs for electrical professionals. Another valuable resource is the International Association of Electrical Inspectors (IE). The IE is a professional organization for electrical inspectors. The IE offers training and certification programs for electrical inspectors. In addition to these organizations, there are also many other resources available to help you stay up to date on the NEC and other electrical codes and standards. These resources include books, articles, websites, and online forums. It's important to take advantage of these resources to ensure that you are knowledgeable about the latest codes and standards. Now, let's reiterate the importance of consulting with qualified professionals for all electrical work. Electrical work can be dangerous, and it's essential to have the skills and knowledge to perform the work safely and correctly. Qualified electricians have the training and experience to install, repair, and maintain electrical systems in accordance with the NEC and other applicable codes and standards. They can also help you to identify and correct potential electrical hazards. When hiring an electrician, be sure to check their credentials and references. Make sure that they are licensed and insured. Also, ask them about their experience with similar types of electrical work. It's also important to communicate clearly with the electrician about your needs and expectations. Be sure to provide them with detailed information about the scope of the work and the desired outcome. Finally, be sure to get a written estimate from the electrician before they begin work. This will help to avoid any misunderstandings about the cost of the project. In conclusion, electrical safety is paramount. Always prioritize safety when working with electricity, and always consult with qualified professionals for all electrical work. By following these guidelines, you can help to prevent electrical hazards and to ensure the safety of yourself and others. Consider these points when working on or inspecting electrical systems.